Hi, and welcome to our webinar, Adopting AI, Picking the Right Problems to Solve. I'm Abby Lundberg. I'm a business technology researcher and writer, and president of Lundberg Media. I'll be moderating today's discussion. I love the focus of today's session. Faced with so many possibilities, how do business leaders pick the right problems to solve with AI? Most are aware that AI has a potential to transform their businesses. What's less clear is how to identify which problems or opportunities best lend themselves to AI solutions. It can be hard to know where to start and how to move forward. We have a terrific slate of speakers to help us sort through these challenges today. Kimberly Neville will start things off. Kimberly is a strategic advisor at SAS and an expert in the areas of advanced analytics, information governance, and data-driven culture. She helps clients understand both the strategic value and the practical realities of artificial intelligence and digital transformation. Kimberly will be followed by Monica Livingston, Senior Director of AI Sales at Intel. Monica's team helps end customers implement and deploy their AI solutions. She'll take us through the different flavors of AI, choosing the right tool for the job, and what it takes to be successful. Pete Smith, Chief Analytics Officer and Professor of Modern Languages at the University of Texas at Arlington, will share some of his practical experience with AI. Pete founded UTA's Office of University Analytics, and he co-founded the Learning Innovation and Networked Knowledge Lab. By the end of the hour, you'll have a clearer idea of how to choose the right use cases, and just as important, understand where AI isn't the best option. Welcome to you all. Kimberly, I'll turn it over to you.
Thank you, Abby. Welcome, everyone. I'm going to provide a very brief intro before turning things over to Monica and Pete to dive deep as we explore two key questions. First, what are the types of problems AI could be used to solve? And second, what problems should you use AI to solve in the context of your organization? Now, the term artificial intelligence, or AI, as we'll refer to it, can mean different things to different people. Here at SAS, we define AI as the science of training systems to emulate tasks through learning and automation. If we can kind of just pop forward there, maybe, and then to the next one as well. Now, your definition may vary, but AI generally refers to non-rules-based probabilistic learning systems that use at least one of these technologies. So machine learning, or ML, deep learning, or DL, natural language processing, NLP, and computer vision, which we may refer to as CV, because we're lazy. Now, more importantly, AI systems, regardless of the specific technology, share some common characteristics. And namely, they learn from experience, and they adapt or may change their answer in response to new input. An experience in this case is simply the data on which the AI model is trained on and subsequently exposed to in production. And today, AI systems are typically used to either automate or augment key decision points or actions. They are also enabling us to really understand and engage more intuitively with the world around us using things like words and pictures. So the profusion of chatbots, for example, is driven by natural language processing. Now, if you're ever uncertain of whether a given system really uses AI or not, Karen Howe created this really simple and intuitive rubric to help differentiate AI from non-AI by answering questions that distinguish, for example, whether something is really just a fancy camera or computer vision in action. So this can be a helpful and fun way to think about the problem. But all joking and technical definitions aside, AI is, as Michael Wade points out, an often expensive tool. And he says a lot of people want that hammer so they can whack things. But getting value from this tool requires us to apply it to the right problems. So in other words, just because we can use AI to solve a given problem, it doesn't mean we should. So what are the characteristics of good AI problems in practice? First and foremost, they are meaningful. In other words, they solve a problem that your organization really cares about. And I think it's really important that we recognize here that value from AI doesn't typically come from just solving one big, hairy, audacious problem in a single go. It usually comes from solving a lot of discrete problems. So things like reducing the time required to process a loan application from 2 to 3 weeks to 5 minutes isn't sexy, it's not really fun, but it certainly completely changes the customer experience, and it provides a differentiated value-added service. We're solving a problem that the company and the customer care about. Now, AI problems are also well-bounded. These tools are not independently creative. They only perform well in circumstances they were trained to recognize. So identifying problems with well-prescribed inputs that may be combined to produce a well-bounded prediction or categorization is key. If we can just go back to that last slide for just a few more minutes, that'd be great. Thank you. And as you all know, AI systems run on data. They run on lots of data. And certainly techniques for training systems and training AI systems on so-called small data are very much rapidly evolving. But today's systems mostly rely on large historical training sets. So if the data to fuel training doesn't exist, or if the data you do have doesn't reflect your future state environment, AI is likely not the right answer. COVID, for example, initially broke many advanced analytics and AI algorithms because the new behaviors were just so completely out of line with what happened in the past and what the systems were trained to detect. So this brings us to the next point. We want to make sure that we're applying AI to problems that are complex enough that because developing AI takes significant time and effort. And that time and effort is involved not just in development, but also in monitoring and maintaining the systems over time. So you really want to make sure that the ROI or the value justifies that investment. And so practically, this means that AI is best applied to problems that happen at scale. So where decision points or actions happen at a frequency, a volume, or a pace that benefits from either automation or augmentation. Now, with that brief introduction, I'm going to turn it over to Monica, who will provide more insight in determining when AI is in fact the right tool for the job.
Thank you, Kimberly. Hi, everyone. So I'm Monica Livingston. I run an AI sales organization, a sales enablement team at Intel. And my team works with end customers to deploy AI applications at scale. And of course, the topic that we're discussing here today is one that I encounter with customers all the time. So, but let's start with why we're having this conversation now. And it really all begins with data and the fact that we are accumulating a lot of it. Stats like a single internet user generating 25 gigabytes of data each month, or a smart car that generates 50 gigabytes of data per day, or a smart factory generating 1 petabyte of data per day. These just show how much data we now have available as the explosion of devices really define all of our interactions today. But this data only can be turned into actionable insights. And in order to get some sort of use out of the data, you have to prepare the data in such a way that it can be input in some sort of analytical form. And then you have to decide what algorithm is best suited to give you the kind of insights that you can use in your business. And this is generally get onto my soapbox and say that AI is not the end game. Nobody should be kicking off an AI project just to do AI. These projects need to be tied to a business need, and AI needs to be a valid means by which a business need can be met. It's essentially a tool. So when you're thinking about each potential project, you need to make sure that it's tied to actually solving a business challenge. AI is extremely data hungry. Some rules of thumb are 12 months of data for forecasting and predictors, and this is just for training. Or for image detection, you need at least 1,000 images per class. And I've seen several customers stop pursuing an AI solution because they simply had not collected enough data to train their model. So as you're looking at an opportunity assessment, you need to make sure that you have the data. You need to assess your data needs early in the solution process. Other considerations are costs and regulations, and they also need to be evaluated early because AI solutions can be extremely if not managed correctly. And we'll talk a little bit more about regulation, explainability later. But let's go into an example. And I think it's important to step back to think about whether AI is even necessary to solve your challenge with the greatest efficiency. And then if so, which approach is each problem demands a different solution based on the data. So let's look at an example where a manufacturer is looking to apply AI to improve their operations. And they have 4 problems to solve, and let's walk through. So the first one is, how many parts need to be manufactured? If this manufacturer has a long history of steady supply and demand, they only need to look at that data to determine how many parts to manufacture next month. This would be an exercise of analyzing historical and supply data and doesn't really need any sort of AI analysis. And then, of course, the type of output that you're looking for from a system like this is an actual number of parts to be manufactured that month. What if then they want to know what their production yield is? And let's go ahead and stay at the previous slide while we go through all these 4 examples. So then let's imagine that this manufacturer experiences the fluctuations in yield from month to month. And then in order to accurately predict what their yield will be the following month, they need to build a model that correlates all the variables that might impact yield. And you can think of temperature, humidity, raw material, volume, and so forth. So this will be a statistical model with potentially some machine learning elements to determine the interdependence between a large number of factors that could affect yield. And the type of response that you're looking out of the system is something like, at current conditions, yield would be X%, a Y% affected. So then the next problem that they want to solve is, hey, we have a lot of parts going down our manufacturing line, which ones have visual defects? And in this case, you can rely on manual inspection, but it's not necessarily the most practical, time effective, or cost effective way. And this is where deep learning can come into play, and they can now build a highly accurate neural network model that automatically detects the defects in the part images. And to do so, they'll need a large database of known good and defective images to train that deep neural network. And then you can use that neural network for inference, essentially to infer whether or not there are defects in the images of the products as they roll off the manufacturing line. And the response that you would want from this system is something like, part A is defective, or part 1050 is defective. And then finally, the last problem that they're looking to solve is, can my robotic arm learn to get better? And they would like to increase yield by enabling the robotic manufacturing arms to adapt to environmental conditions. So again, with deep learning and specifically reinforcement learning, their robotic arms can now learn on the fly based on positive, negative feedback on their actions. So as you can see from this example, algorithms using AI are diverse, and there's a fair amount of expertise needed to determine the most cost-effective and performant approach. You can very easily spend a lot of money on AI if your team doesn't pick the right algorithms and the appropriate infrastructure that they need to run on. Next slide, please. It's worth mentioning that AI is interdisciplinary. An AI problem usually consists of several algorithms, both analytics, machine learning, and deep learning, and they don't work in a silo. They have to work together. So to take this point a bit further, let's look at the 4 broad categories of AI. So there's supervised learning. Next slide, please. And this is using data. One more. Oh, okay. Go back one. Let's stay on this one. Okay, so there's supervised learning. So essentially using labeled data to teach models to perform a useful function. Supervised learning is most commonly used in speech recognition, spam detection, object recognition, and so forth. There's unsupervised learning, which essentially extracts insight from unlabeled data, and we most commonly see that in customer segmentation. There is semi-supervised learning, which is using a combination of labeled and unlabeled data to extract insight from data. And then usually this is used because you have a limited set of labeled data, and it's used in things like text identification, which would require a significant amount of data if to be labeled if you had to just use labeled data. And then there's reinforcement learning, which essentially learns to, over time, to make the best possible decision through trial and error in areas like robotics, automation, controls, recommender systems, and gaming. So there are many more approaches on how you would implement these 4 kinds of learning. The Venn diagram here is a simplification of those approaches. The biggest bucket within AI is machine learning. And then a fast-growing subset within the machine learning category is deep learning. This approach uses the layered neural networks that learn from data to solve problems that are generally difficult to reverse engineer. And keep this in mind because we'll come back to this. But let's now look at just 2 examples of how machine learning works. So the first subcategory that I'll look at is called clustering, and this uses a k-means algorithm, which is a type of unsupervised learning. In this case, we're trying to categorize shoppers in order to target advertising spending, with shoppers plotted based on past purchases, which is the vertical, the y-axis, and purchasing power, which is on the horizontal x-axis. In this example, the low and high purchasing power groups, the green and the blue, don't buy much from the store. In the middle, you have 3 groups with decent purchasing power that purchase a little, like the yellow group, a good amount, like the red group, or a lot, like the purple. So once you have these groups classified, you probably want to figure out what the differences are in those groups and focus your advertising on how those specific characteristics impact their spend. So now let's look at the subcategory of deep learning known as image recognition. In this next example, the purpose of the deep neural network, next slide please, is to classify the picture into one of the 3 different categories: a person, a bicycle, or a strawberry. The first step is known as training, so labeled images are input into the network in order to adjust the internal model weights. When you're satisfied with the trained accuracy of your neural network, the model weights are frozen, and then the trained model can be used for inference. In the inference step, you just feed an unknown image into the trained neural network to allow it to infer what's in that image. So now that we've talked generally what AI can do, let's completely shift gears a little bit and talk about explaining AI. To jump straight to the point, this is the next slide, please. Deep learning is extremely powerful, but it's not explainable. And many business applications need to be explainable in order to pass legal, regulatory, and ethical implications. The data that I'm showing here is from a chief data scientist survey, and it shows that model explainability is considered a challenge by 46% of the respondents, and that it's the most important technology development over the next 1 to 2 years as AI becomes more prevalent. So it's not just the model that you use. You also have to keep in mind how much of your results you need to explain. Because there's still considerable skepticism in trusting AI models, let's look at what explainability actually is. Can we move? Yeah, there we go. So explainable AI needs to be understandable, needs to be comprehensible, transparent, and accurate and complete in the explanation. And really, explainability is key in accelerating acceptance for AI and also providing a check to that technology. Explainable AI is a set of details and reasons for how an AI model produces its outputs, such that humans can understand these outputs and justify them. So let's look at some problems that can be caused by black box AI. Next slide. Yep. The bubble examples here are examples of high-profile problems that are associated with incorrect results from AI systems. Now, most of these resulted from having bias in the training data, but it could also be a bug in the model itself or insufficient data. Take the example of the airplane picture. This picture has elements of a plane on the tarmac, and so even a sophisticated image recognition system is not able to place it in context. It essentially thinks it's an airplane parked on the tarmac. Now, if this is for safety or you're trying to make a decision based on this, this is obviously a very big issue to have misidentified this. Similarly, vision systems can be gamed. In the stop sign example here, placing stickers strategically on the stop sign made the AI system incorrectly interpret it as a speed limit 45 sign. And in case of autonomous driving, this would be, again, a big issue. So the broader context and explainability is needed in AI so that we can ensure that AI is being used appropriately. So let's now take a look at when AI needs to be explainable and when it doesn't. If you look at any system that makes decisions about people, that requires explainability. Think of criminal sentencing, loan approval, hiring, and so on. Also, when AI makes decisions in a closed loop, like autonomous driving, military drones, explainability is extremely important here. And then, of course, where there is regulation. GDPR in the EU, for example, defines instances when a right explanation is needed. But where is explainability maybe not as important? So when we look at AI that generates ideas and insights that can be tested before deployment, I mean, even in areas like identifying compounds for drug discovery, for example, once an AI model identifies those compounds, a lot more testing needs to happen before that drug is actually brought to market. And maybe it's not crucial to know why AI identified those specific compounds because there's a lot more testing that happens on top of that. Also, when AI generates a list of options for humans to interpret, like recommendation systems, for example, for online retailers. And in this case, think of the May We Recommend section. Those are all AI generated today. And frankly, I don't care why a store is recommending that I buy a yellow sweater after I've already put a pair of jeans in my cart. It's not important for me to really have that justification. Or think of search engines, for example. It does not necessarily matter why that search engine placed one result on top of the other. These all might not need the same level of explainability as systems that make decisions about loan approvals, for example, and who gets one and who doesn't. So when it comes to explainability, you really have to look at the particular AI use case and the context in which it's being used. So as most things in life, you're faced with a trade-off between model accuracy and explainability. As we're evolving from simpler models that are conceptually easy to understand and interpretable, like clustering, like decision trees, to the more complex models like convolutional neural networks and deep learning, we find that explainability decreases because in a lot of these complex models, the models themselves define the factors and the weights, and you don't necessarily have visibility into why that neural network decided that airplane is parked on the tarmac. There's a lot of different factors that went in. So when you're considering what AI model to use, you need to keep in mind that this trade-off exists and select the model that gives you the right balance between explainability and your regulatory needs and the accuracy of the model. So to wrap up my section, a couple of closing thoughts. AI can be extremely powerful and useful for your business. Next slide, please. But AI is not the answer to everything. Don't use AI where an analytics solution is sufficient. And finally, determine the need for explainability based on your use case, and then take into account functional, legal, regulatory, and ethical implications to determine specifically how you need to solve the specific problem that you. So thank you for your time. That wraps up my session, and I will turn it over to Pete.
Good morning, good afternoon, good evening from wherever you may be joining us. My name is Pete Smith, and the context I'm going to speak about today is the higher education context. In particular, I'm going to talk about how we apply some of these same concepts that you've just heard Kimberly and Monica talk about to our particular enterprise. As a bit of background, the University of Texas at Arlington is a large public institution in the University of Texas system. We have over 60,000 students. We are a Carnegie Research One university, as well as an HSI, minority-oriented enterprise as well. And so we believe we are a wonderful example of what higher education looks like in the 21st century. But the image I'd like to leave you with today, interestingly, is about the weather. As we have formed a new unit here on our campus, University Analytics, and I'll provide you some staffing and other information about our unit in a few moments. And as I moved around campus talking about the power of AI, and in particular, the power of models and model data outputs and how those differed from data systems, I would go home at night and notice that my weather person certainly was able to understand and talk about models pretty much on a nightly basis. And as you now watch television, if you are still of that generation that watches the evening news, you will begin to see that many of your weather forecasters make use of model data on a regular basis and translate that or interpret that for the listening audience. And I will come back to that point. On the next slide, you will see several of the ways that an institution such as my own might approach AI targets. Where might we point our capacity in AI first? I would go back to Kimberly's checklist. We certainly looked at, when we formed the unit in 2015, for problem space or research areas where the questions were meaningful and complex, data rich, and could be scaled, and to a certain extent were well bounded. And in the end, I'm going to actually come back and share here in a moment some of our key data processes that were the basis of our first AI experiments and in currently our AI that's in production. Another strategy you may take in setting your first questions relative to AI, if we go back to the last slide, what are other enterprises in your domain choosing as their AI questions? They can oftentimes be a very good lead for you in thinking about AI problems. You may take a situation-based strategy or approach. All of us sit in meetings or see decisions that are taken in ways that I don't want to use the word dumb, but you might say other than smart. And you may leave a meeting or leave a decision-making session thinking there's got to be a smarter way to do this using the data. One strategy that's frequently spoken of in the AI industry is this notion of low-hanging fruit, finding a small, easy to define problem that you can attack and solve fairly quickly. I tend not to be a big fan of low-hanging fruit. I tend to make sure that the AI decisions we make are driven more by core business processes, in part because of what you see on the next slide. One of my favorite quotes about low-hanging fruit, of course, is you always have to watch out for low-hanging branches. And I've always wondered whether the metaphor of low-hanging fruit is even one that really should be guiding us in some of these very complex discussions. But as you move to the next slide, you'll see in my educational context, we can identify strategic business processes that were central to the enterprise. So as an academic institution, we are an academic enterprise. We are also a very large business enterprise at the same time. We are, in essence, a billion-dollar enterprise in addition to being an academic institution. We quickly identified several key areas where we were data rich and where problems or AI-driven solutions could assist us to better do what we do as educators and as an enterprise. We looked at recruitment data, admissions data, student success data, workforce data, sometimes called destination data, where our students end up in the workplace and how successful they are based on their learning at our institution, development at our institution. In the end, we zeroed in on student success and moved very quickly to set up an office that oversees modeling of our student success. And we took the step of using a third-party vendor that specializes in student success modeling. Could we have staffed up, built a model for student success, deployed that out on campus to faculty, staff, administrators? Yes, we could have, but we did the calculations and found the third-party vendor approach was something that was very important and useful for us in order to bring student success modeling up and running in a very short period of time. And so the message there, I would say at the start, is you don't necessarily have to create whatever AI area or solution you finally land on for your particular domain or enterprise. You may find third-party vendors or modeling expertise in other parts of the enterprise can easily be utilized for the target that you do eventually pick. If you go to the next slide, you'll see one of the standard screens that an advisor or an academic administrator may wake up to every morning here at my institution. Overnight, we generate a model for each of our 60,000 students, looking at both information from the student information system as well as our learning management system, currently Canvas. We are literally deep in data about students and their engagement, and we provide persistence predictions for every student every day, complete with explainability. An advisor can drill down and see that a student who was, for example, in a bucket that throughout most of the semester had predicted a very high degree of success for that student has suddenly slipped into a high or moderate bucket. And here are the reasons that student's prediction may be slipping, and here are some of the actions that you can take. So to recap, we chose student success as a key business function at our institution, and we developed and in using third-party vendor capability, rolled out AI modeling, machine learning modeling that allowed our constituents on campus to make those smarter decisions. Those advising sessions will happen in a different way this morning. That conference between a faculty member and a student will happen in a smarter way this morning with this data and modeling. An administrator looking at how our students are engaged over the course of the semester will have a different view due to the modeled data. And if we move to the next slide, please. You will see that we begin to make a variety of decisions. The phrase we use on campus is not data-driven, but analytics-driven. We are trying to build a culture of analytics, and so a wide variety of decisions are made based on the overnight modeling of our students' engagement and our student success. One of the first decisions that came up involved optimizing of university advising, and so our vice president, who oversees that area, utilizes the data coming out of our student success modeling to provision differently, providing, for example, students perhaps a longer advising appointment than a shorter one, or more rapidly escalating students to scaffolding services like writing centers or math emporiums. A whole variety of decisions can be made once the model data appears on their desktop every morning. One of the things that we also believe sets the UTA apart from other institutions, if we could go to the next slide, is our focus on the widest variety of the data itself. You are awash in quantitative data. You are also likely awash in your enterprise in qualitative data, sometimes called thick data, or the Gartner term is X data. This is language data, this is video, this is audio, this is visual, this is IoT data. All of the streams that you have around you that help you better understand or better carry out your business processes, your strategic processes, better understand your customers, in our case, our students, for success. The famous article in this area that has really driven some of our thinking is the idea from Tricia Wong, the data ethnographer, that big data needs thick data. You should also be thinking about, for example, the language data that you have around you and the benefit that analyzing it and bringing it into your models may bring. And I highly recommend her reading and work in particular as you're thinking about the broadest set of data that you have available and zeroing in on your strategic needs relative to AI. One of the ways that Dr. Wong's research and her company has us thinking about data, you will see on the next slide, is that there are problems that require discovery rather than optimization. Some of the things I have been talking about so far today in student success were optimization. Could we optimize advising appointments or make more efficient our handoff to a student to the writing center who may be struggling with composition? But there are other problems and other areas in your enterprise that you will gain insight from through more ethnographic methods. And on the next slide, I have a variety of how these data points may be sitting in your enterprise. All of us are looking and working to collect the voice of the customer. What words do our customers or students say in the processes in which they are engaged? We collect surveys. You likely do interviews or other sorts of studies in your institution or enterprise. We have a wide variety of student writing, curricular artifacts. And in fact, we are using our capacity in this sort of data, in thick data, as a way to better understand how students learn over periods of time. We can look at student writing and artifacts to show conceptual development. And so, for example, in our quality enhancement plan, which is part of our every 10-year accreditation, we will share analyses of our thick data collected on campus using AI or machine modeling techniques to analyze it to show conceptual development or change on the part of our students over the time that they will spend with us here at UTA. If we move to the next slide, you will, I think clearly as you were thinking about your enterprise, know that you will too have a variety of what we call unstructured data, language data. And as Monica and Kimberly mentioned, you may also have audio, visual, image, or a variety of other data sets. And there are strong research communities in all of these areas asking us to bring insight from the data that we do have on campus in this format. If we could skip forward to the next slide very quickly, we actually bring a variety of tools, and a tool set exists for dealing with all of the various modes of data you may be collecting. This is actually one of the ways that we put into quantitative form student writing or survey responses in order to bring knowledge or summary of topics or the emotion in the writing or the concepts that we see in the writing to decision makers. On the next slide, I have some summary thoughts. Very quickly, just to give you an example of where we are as an institution, the unit that serves as the central hub for all of these activities at our academic enterprise is called University Analytics. We are a group of more than 20 business intelligence and analytics specialists. We are essentially the data science shop for UTA. The majority of individuals are data science trained at the master's or doctoral level, and most of them have specializations. They may specialize in data engineering or, for example, the analysis of unstructured data, forecasting, and some of the other ways we might think about using our data in more advanced analytics. But I would encourage you, even if you do not have the wealth of staff or capacity in your enterprise, even if you are simply starting to move forward in some of these areas, looking for AI targets and pathways to bring those AI discussions to fore, I would say remember your weather broadcaster. He or she does not collect the data, does not build the models. They don't program in R or PyTorch or TensorFlow, but they are expert at understanding the modeled data output and translating or interpreting that for their users or constituents. And that is an increasingly important role we are seeing as we move forward into these notions of how AI not only is selected, but how it has impact across your institution. And on my last summary slide, you will see some additional thoughts. Look for your business critical decisions. I would encourage you not to look for low-hanging fruit. You do need to watch out for those low-hanging branches. Remember that if you don't have capacity in your enterprise, you can move forward for a variety of ways, whether that's buying a third-party vendor's services or tools. Also, I would note that a variety of tools that you would build today or buy today for your enterprise have AI tasks basically embedded within them. A perfect example is our enterprise budgeting software, which we have just upgraded, comes with a complete set of embedded AI tasks and services, one way to jumpstart AI in a particular area. There is a large community of best practices, notions of AI ethics are on the tip of everybody's tongue these days for a variety of reasons. There are professional organizations such as the IIA, the International Institute of Analytics, which benchmarks and carries out some of these discussions, in addition to all of the major consultancies in the IT world, such as Gartner and so on. But on your last slide, if I leave you with no other thought, remember your weather broadcaster. He or she is a data translator. They are working with models. And in fact, the screen on the right was one that I saw last winter here in the Dallas-Fort Worth area, where my local weather broadcaster, Pete Delkus, said, "Will it snow on Christmas?" And he literally talked us through what each of the models were saying. The American models were predicting snow, the Canadian model and the European model was not. And it reinforced for me that as AI takes root in so many disciplines and domains, we can certainly take use of that and learn from their examples and learn from their metaphors. And with that, I will hand it back over to Abby, and I believe we will move into questions and answers. And thank you for your kind attention.
Great. Well, thank you, Pete, Monica, and Kimberly. Really, really great content. And we do have a lot of questions coming in from the audience. I wanted to start with going back to, Kimberly, what you had to say about the pandemic and the impact on models of people's changing behavior. And I think, Monica, you addressed this as well a little bit in terms of what it takes in terms of having months of training data. So as behavior changes affected those models, what had to happen in terms of the use of companies' AI? How onerous was that? Where are companies in that process, and do they have enough new data now to be able to be using those models all over again? And will it have to change in the future? Kimberly,
yeah, I can go. Do you want to start, Kimberly? Oh, and I think you're still on mute, Kimberly.
Oh no, go ahead.
Oh, okay, sure. So with the pandemic, there are a lot of models that there are a lot of decisions that are different than what we would have taken without the pandemic. The first thing that comes to mind is supply and demand for manufacturing, right? Our purchasing habits have changed dramatically, and so folks that were using AI models to determine their manufacturing forecasts needed to relook at data. And really, it's very common for AI models to decay, and so I think COVID just really accentuated it, and you could really see it. But when you're implementing an AI model, you have to make a plan. You have to assume that data changes over time, and you have to make a plan to retrain. And a lot of these AI models are retrained on a very regular basis. When you have a catastrophic event like COVID, then you do have to relook at, okay, do I need an entire new data set? But even over time, even without COVID, just the regular fluctuations in our habits, in the factors that affect our lives every day, you still have to plan for data drift, and you have to plan for model decay in your training.
Yeah, and it's really interesting because I think and one of the things that we saw, and in some cases we actually walked away, and it wasn't just AI models, it was some of our advanced analytics models as well, from and sort of retrenched in some of our more core analytics, data analytics and statistical bits. So for instance, instead of doing really far-reaching forecasts, we started to do very, very short forecasts. So to your point, Pete, we were doing with a higher degree of uncertainty. But one of the things that we, especially as analytics and data professionals, is we're pretty good at looking at the model. Is the model performant? Is the data profile changing? What we're not always as cognizant of is the environment, right? And what that could be the population or the environment around us changing in which the model is deployed. And so a very simple example might be like something like a self-driving car where it's trained for certain conditions, certain types of cities and certain types of weather. But if we then deploy that car in an area, for instance, in heavy snow or blizzard, it's never seen before, it's not going to perform very well. So one of the things that we need to make sure that we're really monitoring along with the model, along with the profile of the data, is the environment and how people are actually using and engaging the application itself. And so that's a new mindset and awareness and almost a new process we have to put in place. Pete, you may even see this, right? If students start behaving just in fundamentally different ways, or if you are actually good, you're successful in changing student behavior and sending them to do different things, you now need to recognize that the behavior has changed and decide what is it that we want them to do next, which may not have happened before, and how does that model change? So that idea, right, is really why we're always sort of, whinging on all the time about monitoring and maintaining AI over time and why that is so fundamentally different. And accountability comes into place here too, right, which is we are not always clear about what was the expected or intended environment in which we think this is going to operate. What are the conditions we actually tested it for? So Pete.
I would add, our models are completely relearning student behavior today in a wholly different environment than what they had in spring or early in the year, September, even earlier in the semester. Our models have built up just immense amounts of data on student behavior, and as we as institutions pivoted to go more hybrid, in some cases more online, how did our models learn? And in fact, we could watch them learning over time. It had always shown us in the explainability screens that engagement tended to be related to high online activity levels. Now every student has high online activity levels, and we have to watch the models learn how to differentiate and see those behaviors in that different context that you just mentioned, Kimberly.
So we had a couple of questions around explainability. The first question is, what steps can executives take to enhance the explainability of AI in their organizations? And a follow-up to that was, does AI explainability cover the case of identifying bias that may present in training data or in the model?
Yeah, that's a great question. So I would say on the bias, definitely not. Explainability does not cover bias. You have to take different measures to make sure that your data does not have bias in it, and you have to test your models continuously to make sure that to check for bias. Explainability simply justifies why that model has outputted a specific answer. And from an executive level, and I think it's more building the internal processes to understand where explainability is needed and where it is not. There are different ways to drive explainability into models. Some of them affect performance as you're adding additional layers so that you're surfacing that explainability. But I think it's more the awareness and making sure that you've got the process and that you know what regulations your specific application is subject to.
Yeah, and I think that sometimes, and I work for technologists as you do, Monica, and we like technology, and technology can help. And so explainability tools, are good for one thing. They will give you an approximation. They give you an idea. It's not always exact, of what factors the model is taking into account to output a particular decision or recommendation or categorization. What explainability does not do is tell you whether that is okay or not, right? And there's this very, very simple example of where, and you guys may have seen this before, differentiating a wolf from a husky. And what you're able to see with sort of explainability is that, in fact, it was looking at the snow, whether there was snow or forest behind it, determine if it's a husky or dog. And so one of the things that gets really interesting, whether we're talking about is the model fair, is it equitable, does explainability, is to go and look at those circumstances where the model gets it wrong, because that actually tells us probably more about some of the decision making, and then what the boundaries of the things that we need to think about or be concerned about whether a model should be deployed, and what the safety protocols, if you will, or the guardrails around it need to be. Because in that case, we look at, I think it was, a husky, it identified it as a husky. In fact, it was a wolf, and it did that only because the husky was in front of a forest. So now we can start to think about it, right? But the system isn't going to say, I think it's okay. I think it's okay that we identify a husky versus a wolf based on the background. A human's got to look at that, and you can actually then apply that analogy to much more critical issues and areas.
I could give an example. I give an example from higher ed. Sometimes we have to dig into explainability. So our models, for example, saw early on that undergraduate students who register within 7 days of the start of class are decidedly less successful, to a huge degree, almost 10% less successful if they register very close to the beginning of class. But that's not an explanation. That's really, if you will, a behavior, and it requires us to then dig in and find out what was it that caused them to register late. Was their financial aid just awarded very late and allowed very late decision making? In our very intensive 5-week courses, if you register late, you might not get a textbook until you're 20% into the course, which may sort of help us to understand why you're not being successful. So sometimes what the models do learn and the explanations they do give really aren't sufficient or aren't enough insightful to our domain, and you do have to push back on that.
The next question has to do with the use of structured and unstructured data for forecasting the demand for new products. And the question is, if we don't have access to a lot of structured data, but we do have unstructured data, can that work?
I'll jump in and say yes. There's an entire research community as you think about the customer experience researchers who are really thinking about voice of the customer and how to use unstructured data. I would certainly encourage individuals to reach out, learn about that community, learn about the work they are doing. They are really working to raise the value of those unstructured data. Often we simply default to the quantitative side and say my numbers show X, or the numeric trend shows Y. And in fact, the slide I showed with Tricia Wong's very famous TED Talk, she reviews the very famous case where she had some unstructured data based on customer interviews, and corporate had some numerical data, and the numerical data was flat wrong, and her interview data would have guided that corporation. And in the end, that corporation suffered huge losses because they opted for the quantitative and not the qualitative.
So there are a number of questions around the use of third-party companies to do AI. One is just, where can I find companies that do it? How do I price an AI project? And then another question similarly, and you can choose which to answer, was around if you're using a third-party AI model provider, what's the impact of that on competitive advantage? If you're using something provided by a third party who is also obviously providing to others, and then so I'll let Monica and Kimberly address that. But then specifically for Pete, the question was a follow-up: is this an issue in the higher education industry versus the corporate realm?
Yeah, so I think at a higher level, there are a lot of AI solutions off the shelf today. They could be vertical, they could be horizontal, sort of like platform level, where you plug in your own AI solution on top of that, but there's a platform that helps you with the ML ops. I think you need to look at what you're trying to solve, and then you need to look at whether there are applications out there that do it. So for example, if you're an HR department and you're looking for a way to more efficiently screen your resumes, look at what software is available out there first. Always look at what's there. You don't necessarily want to reinvent the wheel. And then you also need to look at, is this something that that you're doing for efficiency, or are you truly trying to drive a competitive advantage? If you're looking to increase efficiency, and there are a lot of good tools out there, certainly look for those specific tools and evaluate those. And I would price them based on your existing practices. What does it cost you to do this today? What sort of cost improvement do you get by implementing this solution? So again, AI doesn't have a certain price sticker in and of itself. You still need to look at it in terms of the business need and what value it's driving for your company. And then if you're looking to drive a differentiator specific to your business, that's when you look at, okay, what's in the market and how can I do it better? How can I do it better than my competitors? And so there are some unique cases in which you could do that, especially if you have some advantages already that you're looking to enhance.
Yeah, and I think that differentiation between am I looking for a tool or a platform, or am I looking for a packaged solution is really important, and we could spend a lot of time on that. But I will say that in either case, particularly with packaged solutions, just like back in the day, and now I'm going to age myself, where we were, doing ERP systems and things like that, and everyone was going to take it off the shelf and deploy it, and then that never happened, right? You end up customizing the crap out of it because, technical term, because you didn't adapt your own business processes or systems to do that. In the same way, even when you're using a packaged AI solution or a solution that has AI embedded, you really need to go back and look at and make sure that the data and the circumstances for which that was trained and is intended to be used matches up with your environment and your population, and then test it on your own bits as well, because there will be unique characteristics of the data in your environment, that your systems and your processes that you're using, that may in fact influence or change how those solutions work. So these are still not things that can be a lot faster, but it's still not something I would say you should just take off the shelf plug in and run.
And I would jump in on the competition front. So as a large public university and a state agency, we use that competitive frame a little bit less, but we do, of course, recruit students and have competing institutions that are also trying to recruit students, for example. But one of the things we see, and in some ways we're more like mission-driven enterprises in what we do. The third-party vendor that does our models does models for about 200 universities and colleges, and we actually benefit from their aggregate modeling. They've just released some reports showing aggregate across various institutions and colleges, some of which are very close to ours, some of which are very different. Here is the impact of some of the machine learning models and their use on campus. So we're in that middle ground. We read Tom Davenport's Competing on Analytics, the book that, by all practical purposes, set this field on its feet. But as a somewhat more mission-driven institution, we taper that slightly.
And Pete, not to be flippant, but I was just going to say, it's also not, it's not so much the insight, it's what you do with it. So your ability to compete on that, right, is your ability to take it and take action. And so that is also where a lot of differentiation will come in with those types of solutions. Is that a fair statement?
Very much so from my standpoint, yes.
So we're really close to the end of our time. I can't believe how fast it went. So as a closing question, and if you can just put this into kind of a tweet size answer, give one pointer, if you could each give one pointer in creating a culture of analytics in organizations that are comfortable with the current way of doing things. What's the one thing that you think could move the needle? Kimberly, you want to start?
Yeah, I will say that instead of trying to convince them of something new, show them how they can do what they're doing today better and faster. So make their job easier today, and you will then develop the right to then have, they will start to think about how to do things differently in the future.
Great. Monica?
So I think in the vein of what Pete talked about in terms of collaboration, where I've seen companies have success is creating that AI center of excellence that shares across organizations, shares success stories, shares implementation practices, so that not every business group has to reinvent the wheel in-house. You actually are starting to develop AI practices cross-company, and that makes them a lot easier to be implemented in practice.
Great. Pete, how about you?
And I would add, based on what we've all said today, there are many pathways, many skill sets, many tools and approaches, expertises you could use to come into this realm. I focused at the end on the notion of a data translator. Sometimes you don't have to be as technical or have as much hardware as a competitor, so long as you have that ability for humans to gain insight from the data and translate that into action. So remember your weatherman, or remember your weatherwoman. I think that would be a wonderful takeaway.
Great. Well, thank you, Pete, Monica, and Kimberly. Thank you for sharing your insights and your experience with us today. And thank you in the audience for your attention and great questions. Once again, I am so sorry we weren't able to get to more of them. A final thank you to our sponsor, SAS. This is an important topic, and we appreciate your leadership in this area. Thanks so much.